In this lecture, I'm going to show you how to sample a normally distributed dataset and the central limit theorem. Now let me close the box plot. I'm going to keep the histogram and the summary. Now I'm going to sample. Let's take a sample. In this case, let's choose the sample size to be 30. We only want one sample. Just in this case, it doesn't matter if you check here with replacement or not. Now, do we want to store the sample? Yes, I want to store the sample, and it's going to be in one of these columns. Seeding. What means seeding? Well, it means choosing one special number or let the system choose a special number to randomly select the sample. So everyone needs to use a different number here. So let's compute. And here we have the sample. Okay. The name is sample of the body weight. One sample from here. And we only have 30 rows. Randomly selected from the original body weight. Now, let's go to Stat, Summary Stats, Columns, and I'm going to select Sample Body Weight. And I want to find the number of items in the sample, the mean of the sample, or the mean, the variance, and the standard deviation. Just those. And also let me choose this other value. Compute. And let's bring this to the mean of the complete data set is 30.51. And the mean of just one sample is 31.34. Very close. Very, very close, these two values. What about the standard deviation? In this case, the standard deviation of the complete data set is 6.83. And in this case, the standard deviation is 8.20. They differ by 1.4 units. It's not too much. They have likely values. Just one digit, 8, just one digit here, 6 or 7. Okay. 6.8 is around 7. and here we have it around 8. So we almost have the same standard deviation. So we don't have a big difference between the standard deviation of the complete data set and the standard deviation of just one sample. If we consider several samples, the mean of the means is going to be almost the same value as the mean of the complete data set. And for the standard deviation, the mean of all standard deviations from those samples is going to be the standard deviation of the complete data set. So let's see if it works. Let's see if it works. I'm going to close this table. And now I'm going to erase the first sample. And then I'm going to sample body weight. How many samples? Let's choose just 20 samples. It's going to be sample with replacement. We want to have all the information split in different columns. And I'm going to choose my number here, 2070. And we can choose to have all the samples in a different data table, or just to keep them in the same data table as the original values. Okay. Okay. Let's close it. Okay, so look, we have here the first sample, the second sample, the third, the fourth, the fifth, the sixth, and so on. We have 20 samples. The size of these 20 samples is 30. Now, for every sample, I want to have its own statistics. So let's choose columns. Now, I want to find the mean. I want to find the standard deviation. Let's store that information. Okay, let's do it also for the original one, this one here. Store in a data table. And let's compute. Here we have the mean. Here we have the standard deviation. And for every single sample, we have the means and the standard deviations. This is going to be the mean and the standard deviation. So let me write here 30.517856. This is the mean of the complete data set. the standard deviation is 683.27, 822. And now I'm going to erase the values. I'm going to rename this column as the population mean, and I'm going to label this one here as the population standard deviation, or sigma, mu and sigma. Okay, now let's find the mean of means, the mean of means and the mean of standard deviations. Okay, let's go to the column name mean, and let's find the mean. And just the mean of means, just the mean of means. Okay, the mean of means, compute. Okay, and the mean of means is going to be just here. Let me copy it. So it's going to be 30.33. And what about the mean of the standard deviations? Seven point 0505. Okay. And now let's compare. If we have the complete population, the mean is 30.51 and the standard deviation is 683. But if we consider the mean of means of several samples, the mean is 30.33, okay, almost the same. And the mean of the standard deviations of all those samples is going to be almost the same. What if we consider this column as a new data set? Well, this data set is going to behave normally distributed because the sample size was greater or equal to 30. The mean is going to be 30.33, but the standard deviation of the means, let's find it. it's going to be 1.29. Okay. So if this is our distribution, this distribution of means has a mean of 30.33 and the standard deviation is 1.29. And what's the relation between the standard deviation of the complete population? You can consider 683 or you can consider 7.05, and the standard deviation of the distribution of means, that is 129. Well, according to the central limit theorem, these two values must be related, and they must be related when we divide the standard deviation of the population by the square root of the sample size. And the sample size in this case is 30. So if we divide 7.05 by the square root of 30, we will have that these two values are related by that formula. Thank you for attending this lecture.